So now you are a world expert in naming coordination compounds. You can look at a formula, determine what the ligands are, what's in the primary coordination sphere, what's in the secondary coordination sphere, what oxidation state the metal has. So it's time to have a closer look at the structures of coordination compounds. And these are far more varied than you're used to seeing as an organic chemistry student. Organic chemists, tetrahedral, trigonal, planar, linear are of course the structures adopted by carbon atoms. So pretty much that's the bulk of what you're interested in structurally in organic chemistry. You can acknowledge bent structures like water, trigonal pyramidal structures like in ammonia, but that's about it. Now, of course, you might remember from the VESPA module, we went further than that for the 5 groups of electrons and 6 groups of electrons around the central atom. But there's a few and far between. The octahedral main group species, things like SF6, only a few of those, only a few of the trigonal Bi-Pyramidal structures and so on. Coordination chemistry, strange structures abound. You can have 2 coordinate coordination complexes, so that's with a metal with 2 ligands, and those of course are linear, no shock there. 3 coordinate, trigonal planar, just like you might expect. 4 coordinate, tetrahedral. However, you can also have square planar 4 coordinate complexes. A metal atom with 4 ligands around it can go tetrahedral, it can go square planar, and some really fun chemistry to decide and predict which would be which. We touch on that in one of the extension topics there, distinguishing between tetrahedral or square planar. You can have a lot of metal complexes that have 5 ligands, and those ligands can go trigonal Bi-Pyramidal, so that's the metal atom with 5 ligands, or you can often see square pyramidal structures like this. Probably the most common, at least in simple chemistry, coordination structure is a 6 coordinate one, octahedral. So that's a metal atom with 6 ligands around it. And you can even get 7 coordinate. You can get 8, 9, 10, 11, 12 coordinate too. But I'm going to stop at 7 coordinate here, which can have a pentagonal bipyramidal geometry. Now, if you think about these bipyramids, you're familiar with a trigonal bipyramid. That's a trigonal plane with a ligand above and below. You can think of octahedron as being a square bipyramid. That's a square plane with above and below, where you can have 7 coordinate, where you have a pentagon, planar pentagon of ligands, 5 ligands there with above and below. You can also have a really fun structure called a capped trigonal prism that has been seen not infrequently in coordination chemistry. So this is a metal with, again, 7 ligands around it. The way I've been forced to draw it is a little unfortunate. It looks like an octahedron with an extra ligand stuck in there. That's not quite true, but I'm also not going to dwell upon exactly what a trigonal prism is. Just to let you know that we have in our coordination compounds far more structures that are commonly accessible than we might see in main group chemistry.